So in the last lesson, we talked about how to solve two-step equations. Finding what the value of x would be that would make the equation true. And our focus was really on the process of solving it rather than just finding the answer. So just as a quick warm-up, if we have the equation 2x plus 1 equals negative 17, if I want to figure out what value of x will make that equation true, what I want to do is I want to get rid of the 2 and the plus 1 attached to it, undo all those numbers around it, and then be able to isolate for x to figure out what it would be equal to in order for this to be true. So remember we talked about the idea of SAMDEB as a way of determining the order that we get rid of things around the x. So right now I have a 2 attached to the x, and that 2 is being multiplied because it's right beside it. And I have a plus 1, which means I'm adding 1 to it. So what I want to do is I want to get rid of the 1 first. So if I have a plus 1 here, I'm going to get rid of it by doing the inverse operation. So I'm going to subtract 1. And if I do it to one side, I'm going to balance it off by subtracting 1 from that side as well. In my next line, I'm going to make sure that I write down everything that I have left. So I still have that 2x. I haven't dealt with that yet. 1 minus 1 goes to 0, so I don't have to write that down anymore. It's gone. I still write down my equal sign, and negative 17 minus 1 will take me to negative 18. Okay, so now I've taken what was a two-step problem and I've turned it into a one-step problem. I still want to get this x by itself. I still have a 2 attached to it through multiplication. If I want to get rid of something that's being multiplied, I do the inverse operation, which is divide. So I'm going to divide this side by 2. I'm also going to divide this side by 2. 2 divided by 2 is 1, so I get 1x is equal to negative 18 divided by 2, which is negative 9. Okay, and again, I can just double check that quickly. I've got 2x plus 1 equals negative 17. If I think that x is equal to negative 9, I can sub it in. I get negative 9 times 2, which is negative 18 plus 1. And when I take negative 18 plus 1, I get 17, which is equal to negative 17. Negative 17 equal to negative 17. So I know I've done that equation correctly. So what I want to look at today is taking the same idea, so taking this equation, but incorporating one more piece, and that is what happens when I have x's on both sides of the equation. Okay? So if you look here, I've got kind of the same foundation, but I've added in an extra x. So I put another 4x in on this side. Okay, so that makes things a little bit trickier because normally what I've done is I've gone to the side with the x's and then I've undone everything around the x so that I can isolate and get the x by itself. However, now I have x's over here and x's over here. So what I can do then is I can do an initial step where I get all of the x's to one side. So for example, if I don't want these 4 x's over here anymore, what I can say is, okay, I don't want those 4 x's over here, so I'm going to subtract 4 x's from this side. And if I subtract 4 x's from this side, then I'm also going to subtract 4 x's from this side. And watch what happens. So 2x minus 4x leaves me with negative 2x. I still have a plus 1. I still have an equals. 4x minus 4x goes to 0 because 4x minus 4x is 0. And I still have a negative 17. Okay? So by doing that first step of subtracting 4x from both sides, I've got all of my x's onto one side now, and now it becomes a two-step problem, which we know how to do because of our practice from yesterday. So again, I want to get the x by itself. I'm going to get rid of my plus 1 first. So I'm going to subtract 1 from both sides. I'm going to rewrite what I have left. So I've got negative 2x equals negative 18. Again, I want to get this x by itself. I want to get rid of this negative 2 attached to it through multiplication. I'm going to do that by dividing both sides by negative 2. Negative 2 divided by negative 2 is 1. And negative 18 divided by negative 2 is 9. So this time I get x is equal to 9. And quickly I can check to see if it's correct. So if I had 2x plus 1 equals 4x minus 17, I'm going to take that 9, I'm going to sub it into my equations, and hopefully we get that the left side is equal to the right side. 2 times 9 is 18. 18 plus 1 is 19. And 4 times 9 is 36. 36 minus 17 is also 19. So I know that I have done that correctly. Okay, one more quick example just to show you, make sure that you see how this works. So I've got another equation here. I've got 6 minus 3x equals 6x plus 33. I want to get the x by itself, but again, I've got that problem of having x's on both sides. So what I'm going to do is I'm going to take the x's and I'm going to get them all to one side. So this time maybe I'll just do the other side so you can see that it works both ways. So let's say I want to take this negative 3x and I want to bring it over to this side. And so I can get all the x's onto the right side. So if I don't want this negative 3x here, I'm going to get rid of it by adding 3x's. And if I add 3x's to this side, then I'm also going to add 3x's to this side. And I'm going to simplify by rewriting my equation. So I still have that 6. I haven't done anything with that yet. Negative 3x plus 3x goes to 0, so that's gone. I still have my equal sign. 6x plus 3x gives me 9x, and I still have my plus 33. So again, that initial step of just getting rid of the x's on this side and putting everything over to this side now makes it a two-step equation. So I'm going to look at the x's on this side now and get rid of the 9 and the 33. So SamDeb, I've got my 9 that's being multiplied, I've got my 33 that's being added. So I'm going to get rid of my 33 first. So I'm positive 33, so I'm going to subtract 33 to get rid of it. 6 minus 33 is going to be negative 27 equals 9x. And 33 minus 33 disappears. So I've got negative 27 equals 9x. I still want to get the x by itself. I want to get rid of the 9 that's attached to it. So I'm going to divide by 9, divide by 9. Negative 27 divided by 9 is negative 3, and 9 divided by 9 is 1x. So I'm just left with x is equal to negative 3. Okay? So when you're solving problems or equations that have x's on both sides, your first step should be just to get all of the x's to one side, and then you can manipulate the equation using the processes we've talked about to get the x by itself.